Measures of position, center, variation, and distribution. The previous units explored the concept of collecting and presenting data. Next, we will focus on the organization and interpretation of that data. Frequency tables and graphs shows how data are distributed over various categories. More formally, we say that a frequency table or graph gives the distribution of the data set. Now you will learn how to supplement graphical representations with numerical statistics that describe the center and variability of the data set. A measure of central tendency is a value that represents the typical or central entry of the data set. The three most commonly used measures of central tendency are the mean, median, and mode. The mean is what we most commonly call the average. The mean of the data set is the sum of the data entries divided by the number of entries. The lowercase Greek letter mu represents the population mean. The uppercase Greek letter sigma represents the sum of all values. Capital N refers to the sample size. X bar represents the sample mean. Notice it is calculated in the exact same manner. The median is the middle value in the stored data set. The median measures the center of an ordered data set by dividing it into two equal parts. When the data set has an odd number of entries, the median is the physical middle data value. When the data set has an even number of entries, the median is the mean or the average of the two physical middle data entries. The mode of a data set is the data entry that occurs with the greatest frequency. A data set may have one mode, more than one mode, or no modes. Can you think of reasons why there would be three different measures of center? There are multiple measures of center because not all data sets are the same. How would you represent the mean of a data set that is qualitative, for example zip codes, eye color, etc.? The mean and median are typically reserved for quantitative data. Even within quantitative data, the mean might not be the best indicator of the center of the distribution. A survey conducted in 1999 found that geography majors at the University of North Carolina had a far higher average starting salary than geography majors from other schools. The reason for the higher average starting salary was due to a single graduate, basketball superstar and geography major Michael Jordan. His first-year contract was worth almost $2 million, while his geography graduates began at roughly $51,000. Let's get some practice actually calculating the mean, median, and mode. A sample of 8 grocery stores are determined to sell the PR Energy Bar. Find the mean, median, mode for these prices. Since we are dealing with a sample, we're going to calculate the sample mean. Again, recognize the mean is always going to be calculated in the exact same manner, whether referring to the sample or population mean. Take all of the data values and add them together and divide by the total sample size, the total number of data values that we have. We see that the sample mean is $1.41. To find the median, we first must place all of the data values in ascending order, right, or going from smallest to largest in cost. From here, we begin to cancel out the largest and smallest values in order to get down to the physical middle quantity. We repeat this process until we're left with either one or two data values. Remember, when the data set has an odd number of entries, the median will be the physical or the single middle data entry. When the data set has an even number of entries, the median is going to be the mean of the two middle data values. The median price of the PR Energy Bar is $1.37. To find the mode, we simply need to determine the value that occurs the most frequently. We've already have these in ascending order. We're looking for values that repeat themselves. We see the mode of the PR Energy Bar is $1.29. Although the mean, the median, and the mode each describe a typical entry of a data set, there are advantages and disadvantages of using each. The mean is a reliable measure because it takes into account every entry of the data set. The mean, however, can be greatly affected when the data set contains outliers. An outlier is a data entry that is far removed from the other entries in the data set. An outlier can change the mean of a data set but does not affect the median or the mode. Michael Jordan's impact on the average starting salary of geography majors graduating from UNC Chapel Hill was an example of an outlier. Once we talk more about variation in the distribution shape, we'll be able to calculate the cutoff in order to determine if outliers exist in our data set. Variation describes how widely data values are spread about the center of a distribution. There are a few key values which we will use to describe the variation of a distribution. The first is the range. The range of a data set is the difference between its highest and lowest data values. Although the range is easy to compute, it can be affected by outliers just like the mean. A better way to describe variation is to consider a few intermediate data values in addition to the highest and lowest values. The most common way is to separate the data into quartiles, or dividing the data set into quarters or fourths. The first quartile or the lower quartile divides the lowest fourth of the data set from the upper three-fourths. It is the median of the data values in the lower half of the data set. Exclude the middle value if in the data set the number of data points is odd. The middle quartile or the second quartile is the actual median. The upper quartile or third quartile divides the lowest three-fourths of the data set from the upper fourth. It is the median of the data values in the upper half of the data set. These three values, along with the minimum and maximum data values from the range, make up the 5-number summary of a data set. The 5-number summary can be visualized by a box and whisker plot as seen on the right-hand side of this slide. Recall, an outlier in a data set is a data value that is much higher or much lower than almost all other values. Let's see how we're going to calculate outliers. Outliers can be calculated by the following formula, plus or minus 1.5 times the IQR, or the interquartile range. The interquartile range is simply the difference between the third and first quartiles of a data set. Let's take a look at an example. The ages of a sample of fans at a rock concert are listed below. Determine the 5-number summary and if there are any outliers. To begin, let's place the data values in ascending or numerical order. From this, we can clearly see the minimum value and the maximum value of the data set. Next, we're going to be interested in finding the median, or the second quartile. Remember, the median value is going to be the physical middle. So once we have the data values in ascending order or increasing order, we're going to begin canceling out the largest and smallest data values until we're left with the physical middle, either one value in the exact center or two values in the exact center, for which we would calculate the mean in order to find the median. The median of this data set is 24. In order to calculate the first quartile, again, we're only going to be interested in the median of the first half of the data set. Again, exclude that median value. Just like before, since we're calculating a median value, begin by canceling out the highest and lowest terms until we get down to the physical middle. Physical middle in this case of the lower half would be 20.5. To find a third quartile, we do the exact same thing. This time we're dealing with the upper half of the data set, once again excluding that physical middle value, the median. We find the third quartile by calculating the median of the upper half of this data. Again, we cancel out the highest and lowest values until we get down to the physical middle. Our 5-number summary, minimum value of 18, first quartile is 20.5, median is 24, third quartile is 30, maximum value was 38. In order to determine our outliers, again, we need to calculate the cutoff. Outliers can always be found by filling in the formula plus or minus 1.5 times that interquartile range. Again, our third quartile was 30, our first quartile was 20.5, and we see that an outlier exists if a data point is 14.25 years above the third quartile or 14.25 years below the first quartile. So let's see what those cutoffs actually are. Outliers for this data set would be below 6.25 years and above 14.25 years of age. There are no outliers in this sample. Remember, the minimum value for our sample data was 18 years of age, and our maximum value was 38. 5-number summary does a good job in describing the variation of a set of data. However, statisticians would typically prefer to use a single number. The single number most commonly used is called the standard deviation. The standard deviation is a measure of how far data values are spread around the mean of a data set. In essence, we are trying to figure out the average distance each of the data points are from the mean. To calculate the standard deviation, we first find the mean of the data set and then calculate how much each value deviates from this mean. We will see in class how the calculator can help us perform this complex formula. Now we can take a look at the distribution's shape, or the overall shape of the graph. A frequency distribution is symmetric when a vertical line can be drawn through the middle of the graph of the distribution and the resulting halves are approximately mirror images of one another. We will spend most of our time with a symmetric graph because a special symmetric graph is what we refer to as the normal distribution. A distribution is said to be uniform when all entries or classes in the distribution have equal or approximately equal frequencies. A uniform distribution is also symmetric. A distribution is skewed when the tail of the graph elongates more to one side than to the other. A distribution is skewed left or negatively skewed when its tail extends to the left. A distribution is skewed right, positively skewed, when the tail extends to the right. Here would be an example of a symmetric distribution. A uniform distribution. Right or positively skewed distribution. Recognize here, outliers are going to exist at the high values. Left or negatively skewed distribution. This time outliers are on the left-hand side of the graph. Recognize the mean gets pulled towards whichever direction the outliers exist.